All right, we're going to be talking about now the interpretation of quadratic effects in the language of the problem. So we have the example here on the median value of the home. This is our y variable using the percentage of the lower status of the population, which is this LS stat. But we are using that variable and also the variable squared. So we're using that quadratic term. We found that that quadratic term has a significant p-value. So that means, in other words, that the relationship between lower status of the population and the median value of the home is actually non-linear. Okay, so how do we interpret these the effect that that variable has on the response? Well, actually, the effect of that is going to have two components: the linear piece, which we call the shift parameter, and also the quadratic term. So when we talk about the effect, just reminding you again what it means. It means what is the change in the expected value of y produced by change in x. Okay, so in other words, how does the expected value of the median value of the homes change when we when we increase the lower status of the population, the percentage, by 1? Well, that change is going to be actually minus 2.33. So if we increase lower status percentage by 1, this is going to change by that. It's going to decrease the median home value by about $2,000. But we have to now consider this second piece. And this effect here, these parameters, is going to be doubled because the exponent is 2. And I'll explain why that is the case in a second. But not only that, we also have to multiply by the exact lower status of the population. So the effect will be all of this. In other words, by how much the expected value of the median homes will change will be based on this equation right here. And we would have to know the exact level of the lower status of the population. Let me explain it in another way. Well, the expected value of the median. So let me think about it in another way. Let's say that we have a variable y and a variable x. And let me just put it this way. Y, the expected value of y, is going to be equal to beta 0, beta 1 times x. And suppose that we have the quadratic term here, x squared. When we think about the effect, what that means is, well, what is the derivative of the expected value of y with respect to x? The derivative is just a fancy term for the slope, the change produced. In other words, that delta that you see here, so it's just telling you what is the change produced in the expected value of y by a change in the x value. And that is what the derivatives mean. We are not going to work with deriving the equation, but I'm just going to show you what it means. If we take the derivative of an expression with respect to x, everywhere we don't find an x, that derivative is going to be 0. So in other words, this term goes away. The derivative of this term with respect to x is just going to be beta 1. And the derivative of this term with respect to x is going to be 2, because the exponent is 2, times beta 2. But now I have to put the value of x because the exponent is 2, and now the exponent is going to be 1. So that is what happens in the in this when we are trying to measure the effect of the variable lower status. This is going to be the slope for the value x, the linear piece, and this is going to be the 2 produced by that effect when we take the derivative. This is going to be the estimate of beta 2, and this is going to be the value of x. So that is how we measure that effect. So in other words, if I have to explain this in the language of the problem, I would just be able to say that the effect produced, the effect of the variable percentage of the lower status of the population is going to be dependent on the exact value of the lower status of the population. If I know that that percentage is 10, then I can figure out and actually do the math in here and get back what the effect will be, the exact effect. Okay. I know that it takes a little bit of thinking about this, and if you're not a person that, if you're more of a visual person that instead understand things in another way, then I'll explain it another way. Let's think about it this way now, in terms of a graph. Just think of the effect as the, let's say, the effect is the same thing as think about it as the slope. Slope is like the change in y produced by a change in x. Remember when you were back doing, let's say, high school algebra, that you might have seen the slope as the change in y produced by a change in x. So that's probably one way you saw that. But now we are going to think about it this way. If the model is this, y is equal to, let's say, b0 plus b1 times x plus b2 times x squared, and this is y hat, and it's that blue curve right here. How can I measure the slope? How can I measure the change in y produced by a change in x? Well, it's going to depend on where you are on that graph. Let's say the percentage of the lower status of the population is 5%. Well, what is the change in y produced by change in x? Well, the slope right here is this. It's a little bit steeper than if you measured it in somewhere else. So I would have to know the exact value of the lower status of the population in order to know what effect. Again, effect is the same as slope. It might be that in that case, the change produced in y is going to be, if you changed the lower status, the percentage of the lower status population from 5 to 6, it would produce a change on that slope that it might be very negative. I mean, it might be, let's just think of a number here. Let's say -3. Okay? But that would not be the same change as if the lower status of the population was 20. In that case, if we look at it here and we measure that change, it's not going to be as steep as that change produced when the percentage of the lower status was 5. This change, and again, think about the slope in this case, is going to be maybe not as steep as the one that we saw before. So, in other words, that effect will be twice the value of the parameter estimate, but we need to know the lower status of the population, the exact, in order to be able to know that specific slope. Hopefully that makes sense. We'll see more examples on that in practice, and we will see it with another different variable if that doesn't make sense. But I wanted to show you that the effect is measured by these specific equation. So it's measured by the equation that contains both a linear piece twice the quadratic piece multiplied by the ls stat, the value of the original variable. All right, so hope that makes sense for you.